We're going deep on Sir Isaac Newton. And if that name just brings to mind, a simple genius under an apple tree ready to hand down these universal laws, you are about to meet a far more complex, a far more contradictory, and honestly, a pretty frightening figure.
That's it, exactly. That's the mission here. When you dig into the mountain of literature about Newton, you start seeing this really strange pattern.
Right.
The accounts contradict each other all the time.
Yep.
Our sources point out it's almost, and I'm quoting here, as if there were several Newtons, or that he lived several lives.
So our job is to put those different people back together.
Precisely. To synthesize them. The brilliant mathematician, the isolated academic, the obsessed alchemist, and the political power broker. We want to understand the full man who basically codified the age of reason.
We're skipping the marble bust and we're getting into the reality. We're going to explore that lonely child who was obsessed with measuring time, yes, the architect of gravity, but also
the controversial public figure.
And the ruthless detective at the Royal Mint. A guy who personally hunted down criminals, and the lifelong secret alchemist looking for the philosopher's stone.
It's a journey defined by conflict and genius.
Okay, let's unpack this. So we have to start at the beginning, in his childhood.
We have to. And we have to begin with the backdrop, which was just one of violence and total upheaval.
Yeah.
Isaac Newton was born in a small village, Woolsthorpe, in Lincolnshire, in 1642. This is right at the height of the English Civil War.
And this isn't some, peaceful countryside setting we might imagine.
Not at all. This region was truly suffering. It was caught right between King Charles's Cavaliers and the parliamentarian forces.
The Roundheads.
The Roundheads, exactly. And some of these brutal factions they called the Levelers.
And the sources really detail how bad it was on a personal level for just, the common folk.
Oh, yeah. Residents, knights, gentlemen from nearby Grantham, they were filing official complaints about the inhumane actions of the Cavaliers. I remember that line. They said the soldiers had lost the natural softness common to Englishmen and Christians.
And that they'd become almost as cruel as Turks, which, tells you everything about the level of fear and hatred at the time.
It speaks to a total societal breakdown. And yet, amid all this cruelty and fear, Newton's family estate, Woolsthorpe Manor, it's like it had some kind of providential protection.
It was spared.
Mostly, yeah. It was spared any major physical damage. When you look at the family's records of their losses, the entire impact of the Civil War on them was just a few lost sheep and a minor apple harvest.
A contribution.
A contribution, right. So Newton grows up sickly, frail, but he's geographically shielded while just soaking in this underlying tension and fear of the age.
Okay, so now we get to the critical psychological event. The one that a lot of researchers think shaped his entire personality.
A flashpoint.
His father died before he was even born. And then, when he's just 2 years old, his mother, Hannah Icegoff Newton, she remarries.
To the wealthy and much older Reverend Barnabas Smith. He was 63.
And this is where the trauma begins.
It is. Because Hannah left the 2-year-old Isaac. She just left him in the care of his grandmother to go live with her new husband.
At age 2.
At age 2. And this act of abandonment at such a formative age is, well, most researchers consider it the critical event in his psychological development.
You can see the pattern, can't you?
You can. The intense isolation later in life, the deep suspicion of others, that hyper-volatile reaction he had to any kind of intellectual criticism.
Which we will definitely get into.
Oh, we will. It can all be traced back to this initial, profound sense of betrayal.
It really sets up this core tension in his life, doesn't it? This need for absolute control, for quantitative certainty, as a way to cope with the messy, unpredictable world of human emotion.
That's a powerful way to put it. You're seeing the birth of the personality that demands universal, unbreakable laws.
Because the human world had already proven to be utterly unreliable.
Exactly.
Okay, so let's move forward a bit. Reverend Smith, his stepfather, eventually dies.
He does. In 1653, Newton is 11 years old, and he visits the house in North Witham. And the moment he spends in that house, it tells you everything about who he was becoming.
Right, because most 11-year-old boys would have been drawn to, the valuables?
For sure. The sources note he wasn't struck by the 4 silver vessels, which were, the pride of the house, a real status symbol.
No, he was fascinated by the multitude of books.
A whole library, a wealth of knowledge, all bound in expensive leather, works of the Church Fathers, theological treatises. But here's the really revealing detail.
That's good.
Reverend Smith wasn't known as a particularly learned man. But among those books, Newton finds this thick, leather-bound notebook.
And inside?
Smith had meticulously, almost obsessively, copied down common sayings and phrases for sermons. It's not scholarship.
No, it's systematization.
It's pure systematization of just prosaic knowledge. It shows Newton discovering an early model for how to collect and catalog information, even if the information itself was, pretty mundane.
So the next big catalyst for his genius, and this is ironic, comes from just outright hostility.
At the King's School in Grantham, yeah. His relationship with the Storer brothers, Edward and Arthur, was openly antagonistic.
They just didn't like him.
They found the sickly, quiet runt, as they called him, completely unlikable.
And Newton, for his part, provoked them. He wasn't just a passive victim.
Not at all. He had this mischievous streak. He stole a basket of cherries from Edward and then lied about it. That just made things worse. And this all culminates in a physical fight with Arthur Storer.
A fight that ends up being enshrined in history.
Because the adult Newton, years and years later, when he's making this private list of all his sins, he includes it. Beat Arthur Storer.
Wow.
But the fight itself wasn't the end point. It was a pivot. That conflict just lit this deep competitive fire in him.
So he decides to get even.
Not physically, but academically. He focuses with this incredible intensity on his studies, subjects he had previously despised. And to the shock of everyone, he doesn't just pass Arthur.
He surpasses the entire class.
Easily. He becomes the top scholar. And this unexpected triumph, driven purely by personal resentment and competition, it absolutely set the trajectory of his destiny.
It's funny to think if Arthur Storer had just been a bit kinder.
Isaac Newton might have ended up a mediocre farmer.
Exactly.
And this new relentless drive, it translated into this incredible mechanical ability.
It did. When he was supposed to be in school, he'd often just escape. He found a sanctuary in the attic of the Clark apothecary's house.
And that's where his talent for intricate manual work just exploded.
And he was funding this passion himself, using money from his mother to buy expensive tools, axes, hammers, saws. He was building these complex mechanical objects.
Like a working wooden clock.
Oh, working clock. He replicated the new local windmill, meticulously figuring out every single hidden gear and mechanism. This isn't just a kid playing. No, this is systems analysis in real time.
For sure.
And the anecdotes from this period are just priceless. I mean, you have to picture this bizarre scene with the mouse-powered mill.
Right. So when the wind failed, Newton demanded that his little model keep working. He needed it to work.
So what does he do?
He catches a mouse, names it Miller, and rigs up this whole apparatus. He controlled the speed by using a thread tied to its tail for braking.
And a piece of lard dangling in front of its nose for acceleration.
It's pure genius. It illustrates his ingenuity perfectly. He's using simple, available mechanics and understanding natural motivation to solve a technical problem. He found a dynamic solution.
Even if that dynamic was mouse-based.
Mouse-based, exactly.
Beyond the models, he developed this profound, you called it a timekeeping mania.
Oh, totally. At age 9, he installs one of his first, probably imperfect solar clocks on the church wall in Colsterworth.
But it was at the apothecary's house that this obsession with precision really took hold.
Yeah. That house became his laboratory for time. It was filled with solar clocks, from the basement to the attic. He was meticulously driving stakes into the ground, stretching strain.
Not just to track hours.
No. Half hours and quarter hours. He kept such scrupulous, detailed records that he could accurately calculate the exact times of the solstices and equinoxes.
He became the local timekeeper.
The most reliable one.
Right.
This relentless pursuit of quantitative precision, this need to impose numerical order on the chaos of the world, that's the foundational trait of the future scientist right there.
And crucially, that apothecary's house gave him another seed for his future: chemistry.
A huge one. He had access to botany, anatomy, and chemistry. Jars with these mysterious Latin names, dangerous poisons, strange color changes, explosions.
That's the fun stuff.
All of it. And this tactile, sensory experience fed what the sources describe as his ancient dream to one day see the golden glow in a sooty crucible.
This wasn't just rational science.
No, it was the intoxicating possibility of transmutation. This was the start of his secret, lifelong obsession with alchemy. A field so far removed from the rational, mechanistic universe he was destined to define for the public.
So at the same time, he's building clocks and dreaming of making gold.
Exactly.
To really get inside the mind of this isolated boy, researchers like Frank Manuel did something incredible. They compiled and analyzed Newton's Latin grammar exercises.
And these weren't just translations, they were like windows into his emotional world.
And what they found is well, it's astonishingly bleak.
It is, it's stark. The emotional landscape is profoundly negative and defensive. It is almost entirely devoid of positive sentiment. The word love never appears.
No joy, no desire.
Almost none, with the one notable and kind of funny exception of a solitary mention of his passion for roast beef.
But the pervasive themes, they reflect a mind that's just built on fear and suspicion.
Oh, completely. The phrases from his exercises are things like, "I must be sure he won't harm me," or "You fool me. You are stupid to believe him."
And this deep, ingrained cynicism. You will never make me believe this fairy tale.
And then there's the loneliness. The themes of loneliness echo through everything. Nobody understands me.
What will become of me?
I want to finish all this.
Huh.
And the most desolate one. I am capable of nothing but tears. This is the internal voice of a child coping with deep abandonment. He's constructing these intellectual walls to protect himself from an untrustworthy world.
And that internal language directly mirrors the severe Puritan values that came to define his external life.
Absolutely. The result was this persona built on, as the sources say, cruel self-control, thoroughness, inclination for order, and a powerful desire to use his virtues to stand above all.
This self-imposed structure, it was necessary for him given the trauma, but it also nearly cost him his entire career.
It did. His mother, Hannah, she just wanted him to stay home and manage the farm.
And Newton fiercely resisted. He called the 9 months he spent trying to learn farming a nightmare.
It was only through the determined intervention of some influential people, his uncle, William Icecoff, the headmaster, this wealthy clergyman, Humphrey Babington, that his mother finally relented.
She agreed to send him to Cambridge.
She did, recognizing that his true potential lay elsewhere, even if she couldn't fully comprehend what that was.
So in 1661, Newton finally gets to Trinity College, Cambridge. But the circumstances were not exactly prestigious.
Far from it. He entered as a Caesar, a poor student who had to perform menial tasks to pay his way.
Running errands, fetching things from the brewery.
General cleaning duties, yeah. The records even have these rather colorful disciplinary warnings for Caesars, including specific instructions not to strike the butcher or his servant.
Which suggests a pretty rough and tumble existence, not the image of a serene scholar.
No. And his tutor, a man named Benjamin Pullen, a professor of Hellenist studies and theology, seems to have been pretty hands-off.
Which, ironically, was probably the best thing that could have happened to him.
The greatest academic favor anyone could have done him, because the official curriculum was just completely archaic. His uncle had given him a copy of Sanderson's Logic.
A textbook on Aristotle.
Right, it was the standard reading. But Newton quickly realized that Cambridge was stuck in the past. That same book had been used 30 years earlier. Time had stopped.
The academic strength there was all in studying classics, Greek and Latin, and old Christian theologians.
Right. Most of the scholars genuinely believed that all the worthwhile ideas had already been expressed millennia ago. They saw themselves not as innovators, but as guardians of tradition.
They were just dwarfs standing on the shoulders of giants.
Exactly. That saying from Bernard of Chartres, the giants being the classics, Plato and Aristotle, mathematics and natural philosophy, what we now call physics, were almost entirely ignored.
Just secondary pursuits.
Yeah, and this intellectual vacuum is what really set the stage for Newton's revolutionary self-education.
And it is truly amazing that his monumental passion for mathematics was sparked by something so seemingly trivial: astrology.
In 1663, at the Stourbridge Fair, Newton spent a lot of money, probably a painful amount for him, on an expensive book about Hindu astrology.
And his motive was simple.
He wanted to predict his own future.
But the book, to do its calculations, it required trigonometry. And this starts this incredible chain reaction of self-directed learning.
It really shows his relentless need to master the source material. He buys a book on trigonometry, which of course cites Euclid.
So he has to go back to the sources.
Right, he has to master Euclidean geometry from the ground up. And it was there, immersed in these foundational texts, that he discovered this profound meaning in theorems he had previously dismissed as trivial.
This wasn't about grades.
No, this was about some deep internal intellectual necessity.
And the self-education, it leads directly to his philosophical independence. He starts to distance himself from that classical reverence for Plato and Aristotle.
There's a great notebook entry where he quotes from Charlton, "In philosophy there can be no sovereign but truth."
And he adds his own defiant note to that.
He does. He suggests that monuments should be built for Kepler, Galileo, and Descartes, with the inscription, "Plato is a friend, Aristotle is a friend, but the chief friend is truth."
He's explicitly elevating modern empirical science above the old guard.
Absolutely. He's studying all the key mathematical influences of the era, just absorbing the newest ideas from Europe. Oughtred for arithmetic, Van Schooten and Viet for applying algebra to geometry.
Using letters for known and unknown quantities, he was catching up fast.
So Newton's initial focus in mathematics was on this traditional, really agonizing challenge of quadratures.
Which is basically calculating the area of complex shapes bounded by curves.
Right. And mathematicians of the time really struggled with it. They couldn't find exact measurements for these irregular shapes.
The problem was conceptual, really. How do you deal with a curve mathematically?
The challenge involved finding the limit, the exact area of a polygon inscribed within the curve, but a polygon with an infinite number of infinitely small sides.
This is the intellectual prelude to calculus. It's all about understanding infinity.
And the breakthrough was in infinitesimals. For you listening, just imagine trying to find the area of a big curved pond. You can approximate it by laying down smaller and smaller square tiles.
The smaller the tiles, the more accurate the measurement.
Exactly. The closer those tiles get to zero size, the more accurate your measure becomes. Newton was working on finding the point where the tiles are effectively zero in size, but still useful for calculation. This focus on the limit, it foreshadows his whole method of fluxions.
And then, around January of 1665, we see him making the explicit connection between his math and physics.
We do, in an early work titled On Reflections.
And this was clearly inspired by Descartes.
Oh, without a doubt. Descartes' mechanical philosophy, his rules about the collision and reflection of bodies. Newton was synthesizing the most advanced thinking of his time.
And in this early manuscript, he gives his first formulation of the conservation of momentum.
He does. He writes that equal forces will produce equal changes in equal bodies, because losing or acquiring the same amount of motion, bodies undergo the same change in their condition.
So he's absorbing Cartesian physics, he's applying this advanced geometry he's taught himself, and he's starting to formulate these fundamental concepts of dynamics.
All while the official Cambridge lectures are still stuck on medieval logic. The stage is absolutely set for his intellectual explosion.
Which brings us to 1665. The Great Plague hits London.
And Cambridge is forced to close its doors that August. Newton, ever the proactive planner, doesn't wait around. He leaves a full week early to go back to the isolation of Woolsthorpe.
And he didn't just pack his clothes?
No. He packed his books, his prisms, his lenses, and a whole arsenal of medicinal remedies, dried angelica stems, various herbs, Spanish wine.
He was determined not to waste any time.
And he found the perfect environment. The plague passed along the northern road. You could see it from the manor, but it never touched the estate itself.
So he had this quiet, calm safety he needed.
Reminiscent of the protection his family found during the Civil War. In this period, 1665 to 1667, this is what gets mythologized as the Anni Mirabilis.
The years of miracles.
Right. Which suggests this sudden, effortless, almost divine inspiration. But the sources, they tell a very different story.
A story of just relentless, contextualized labor.
Right. And let's start with the most famous legend of all, the apple.
The apple falling, the instantaneous flash of insight about gravity.
That story was popularized by Voltaire and later confirmed by Newton's niece. But modern research doesn't diminish Newton's achievement. It just places it in the context of immense dedicated hard work and, well, necessary intellectual predecessors.
The idea of an attractive force wasn't entirely new.
Not at all. Robert Hooke, for instance, had presented ideas to the Royal Society in 1666, suggesting that gravity was similar to pendulum motion, and that the force holding planets in orbit varied with distance.
So what was Newton's breakthrough?
It was the crucial step of universal application. His manuscripts show that the key idea was to compare the moon's centrifugal force, the force trying to pull it away from Earth, with its attraction to Earth.
He's connecting the terrestrial with the celestial.
Exactly. The transition from the Earth-Apple system to the Earth-Moon system suggested that gravitation was a universal character of the cosmos, not just some local thing happening on Earth.
But here's where the story gets really interesting. He didn't just have the idea, he immediately tried to prove it with math.
And he failed.
He failed.
Precisely. In his first attempt to confirm the inverse square law for the Earth-Moon system, he used the common geographical measurement of the time, 60 English miles per degree of latitude.
And that number was wrong.
It was inaccurate. And because his calculation didn't perfectly match his theory, he was profoundly disturbed.
The significance of that failure is huge, isn't it? It shows the vulnerability of the genius.
It really does. Because his perfect mathematics didn't match the imperfect geographical data, he momentarily retreated. He started to entertain Descartes' old idea that a vortex force must also be influencing the moon's motion.
Wow. To go back to the vortex model.
It would have been an immense compromise, a rejection of his own revolutionary insight, just because the numbers didn't immediately line up. It wasn't until years later, when he got new, more accurate measurements of the Earth's circumference, that the math finally clicked.
And he could finally discard the Cartesian vortices for good.
His greatness is confirmed not by the single flash of revelation, but by the years of perseverance through failure.
Okay, the other monument of the anti-Mirabilis was the development of calculus.
Or, as he called it, the method of fluxions. And the sources describe his key contribution as the kinetic justification of the infinitesimal calculus.
Let's break that down.
Okay, so forget the complex formulas for a second and just focus on the concept. The challenge was, how do you measure change at a single instant?
Right. If a cannonball speed is constantly changing, how fast is it going at the exact moment it hits the ground?
Exactly. Newton solved this by introducing the concept of motion into geometry. He conceptualized fluxion as the velocity of a process, the instantaneous speed.
And fluent as the general result of that process, like the distance traveled over time.
And here's the intellectual leap. Newton was the first to recognize the fundamental unifying relationship between differentiation, finding the fluxion from the fluent, or speed from distance and integration.
Finding the fluent from the fluxion, distance from speed.
They're inverse operations of the same process of continuous change. That was the key insight.
And we should acknowledge he was building on the work of others.
Of course. His understanding drew heavily on geometric precedents from figures like Cavalieri and Torricelli, who studied surfaces generated by moving lines.
But Newton took those geometric ideas and built this dynamic, unifying analytical framework.
And while some critics later argue that his initial methods maybe lacked absolute mathematical rigor, which was probably necessary given the sheer speed of his discovery, his framework allowed him to apply these methods universally. He could solve problems of motion, area, and volume that had stumped mathematicians for centuries.
A complete intellectual revolution forged in total solitude.
So when he gets back to Cambridge, that rigorous, quantitative approach he mastered during the plague years, it translates into this terrifying scientific fervor.
Especially in his optical research, he started applying that extreme observation to his own body.
Frighteningly so. The experiments he did on himself bordered on physical self-harm. To understand how the eye perceives color and light, he would press his own eyeball with a bodkin, a long, blunt needle.
While his eye was closed.
Yes, deliberately distorting his vision just to observe the strange new colors and forms that resulted.
And even more dramatically, the sun.
He stared at the sun with one eye until light objects looked red and dark objects looked blue. He nearly blinded himself.
The sources say he had to retreat into a dark room for days just to recover his vision.
And his conclusion from this ordeal was classic Newton. Meticulous, detached observation of a near-fatal event. He concluded that imagination alone could excite the optic nerve as strongly as the actual physical stimulus of the sun.
He was willing to risk permanent damage to his body for a single data point.
Incredible. And this painful research led him directly to his greatest invention outside of pure mathematics. The reflecting telescope.
He realized that the standard Galilean telescope suffered from something called chromatic aberration,
which basically blurred the images. Newton theorized the problem was inherent to light itself. He hypothesized that light rays in their primitive state were already composed of different colors, and that each color refracted differently when passing through a lens.
So to eliminate the problem, you have to eliminate the lens.
Exactly. His solution was radical for the time. Replaced the heavy primary objective lens with a concave spherical mirror.
And he was a true artisan. He made his own tools to cast and polish the metal mirror himself.
He did, but his real innovation, the thing that made the design practical, was the placement of a small, flat mirror near the focus.
To divert the light.
Right. It diverted the reflected light sideways to an eyepiece on the side of the tube. This forced the observer to look to the side of the sky, a revolutionary shift in telescope design, which he completed in 1668.
So when he finally introduces his telescope and his color theory to the wider scientific world, the isolated genius comes into contact with the Royal Society.
Founded in 1662, its motto was nullius in verba, nothing on word, a commitment to skepticism and relying only on experiment.
And in 1672, Newton presents his theory of colors as his most significant discovery, and it was immediately criticized.
particularly by Christian Huygens, who questioned how a corpuscular or particle theory of light could fully explain things like colors and refraction. And Newton's deep-seated sensitivity, rooted in that childhood suspicion, it flared immediately.
His reaction was extreme.
Completely. He wrote to Oldenburg, the Society's secretary, expressing his profound desire to be excluded from philosophical discussions. He ultimately resigned, hoping to preclude lamentable incidents of this kind in the future.
He preferred total isolation to any challenge.
Absolutely, and this profound conflict comes to a head in that famous exchange with Robert Hooke.
So Hooke reaches out. He's trying to reconcile, suggesting their minds were equally tuned to derive exact conclusions from experiments.
And Newton replies with that now immortal phrase, "If I have seen further, it is by standing on the shoulders of giants."
But this revered quote, this supposed cornerstone of scientific humility, it was actually a cruel, veiled insult.
The sources strongly suggest that interpretation, given the context of their bitter rivalry.
Because Hooke was physically small.
He was small and hunchbacked. And while Bernard of Chartres had used the phrase centuries earlier to promote respect for antiquity, Newton knew exactly who he was talking to. To suggest he was standing on Hooke's shoulders was likely a concealed, mocking insult.
It just confirms his tendency to use his intellect as a weapon when he felt threatened.
Right. And the feud didn't end there. In 1675, Newton offers his complex ether hypothesis light as corpuscles, a subtle ether for gravity and magnetism.
And Hooke immediately claims the basic ideas were already in his own book, Micrographia.
He did. The Royal Society rejected Newton's memoir, and this just deepened his isolation and his suspicion of the whole established scientific community.
So while he's publicly battling these rationalist rivals, privately, Newton is maintaining this profound commitment to the non-rational.
To alchemy. Both he and his tutor, Isaac Barrow, shared a secret, intense passion for it.
And Barrow grants him access to the laboratory at Trinity College.
A true sanctuary where Newton would spend countless solitary hours, often late into the night.
And this was a serious, long-term commitment for him.
Oh, absolutely. He dedicated 3 decades of his life to alchemy. He truly believed that ancient texts contained encrypted secrets leading to the philosopher's stone, transmutation, even immortality.
The sources give us tangible proof of the physical cost of this obsession.
They do. Newton once admitted that his hair had turned gray, not from studies, but from mercury, the toxic element he was constantly handling.
And he believed his natural hair color would return when he stopped his experiments.
Which, tragically, it never did.
His focus wasn't just on turning lead into gold, though.
No, he was obsessed with extracting the abstract philosophical mercury of metals. He linked the symbolism he read in alchemical texts, specifically the symbol of the lion, with the mineral antimonite, or stibnite.
And here's a fascinating connection back to his physics.
It's incredible. He noted that the crystal patterns of star regal, or the heart of the lion, when you viewed them under magnification, they appeared as rays directed toward the center.
An associative connection to his physical concept of attraction and gravity.
The spiritual quest and the rational quest were secretly informing each other.
But this intense, secretive period was shattered by a tragedy.
A fire, likely in the winter of 1677 or 78, probably caused by an unattended candle, and it burned several of his papers.
And researchers believe this catastrophic loss included work on optics, fluxions, and, crucially, a large alchemical treatise.
Right. The fire also coincided with a period of severe mental distress for him, a real breakdown. The loss of years of work, both rational and esoteric, combined with the departure of his assistant, it just pushed him to the brink.
Following his mother's death and recovering from that breakdown, Newton has this kind of political awakening during the Glorious Revolution.
He does. He successfully stands up to King James II's attempt to force a Catholic degree upon Cambridge, which shows this new aptitude for public conflict.
And he's feeling like his major scientific work is done. He starts thinking about a career change.
And this transition is made possible by his connection to Charles Montague, a brilliant, rising Whig politician who would later become Lord Halifax.
Montague provides the crucial support Newton needed to get into high society.
And this political connection was strengthened by family ties. Montague was the lover, and possibly the secret husband, of Newton's beautiful niece, Catherine Barton.
And Barton was a major figure in London society, a lady toast of the Whig Kit Kat Club.
Which, for you listening, was not some casual gathering. The Kit Kat Club was the definitive political and social hub of the powerful Whig Party.
A place where alliances were forged and careers were made.
Exactly. Catherine Barton's high social standing gave Montague greater access and influence, and Montague, in turn, used that influence to secure a high-status position for Newton.
It was the bridge the isolated academic needed to cross into the world of power.
So in 1696, Montague offers Newton the post of Warden of the Mint. And his job is to manage the Great Recoinage, which was a full-blown national emergency.
The financial system was in total chaos.
It was Gresham's law in action. Bad money drives out good. People were clipping the edges off silver coins, melting the clippings down, and spending the reduced value coins.
So all the full-weight currency was being hoarded or exported?
Which left the country with these widespread shortages of change, paralyzing trade. It was a crisis.
And Newton brings the same rigor he used to calculate the orbits of planets to law enforcement.
He doesn't just manage coin production, he becomes an expert detective. He studies the history of counterfeiting and creates this extensive and expensive network of informers.
He personally invested in this work.
He did. We know he spent £5 just to buy a suitable suit for one of his agents, a guy named Humphrey Hall, so Hall could infiltrate the criminal gangs and gather evidence.
His most famous target was William Challoner, the master counterfeiter.
A formidable opponent. Challoner claimed he was innocent and later tried to buy his freedom with huge bribes. But Newton was just utterly relentless.
He personally prepared the case, interviewed witnesses, collected testimony.
And despite Challoner's desperate pleas to the king for clemency, from the horrific, pleasant death hanging, drawing, and quartering, which was reserved for trees, Newton made sure the conviction was ironclad.
Challoner was executed. It just shows this terrifying combination of intellectual precision and cold, unforgiving determination.
Beyond the crime fighting, he applied macroeconomic strategy. He realized the financial system was broken because imported gold was overvalued compared to English silver, causing this massive outflow of silver.
So he proposed a dual strategy.
Right. Restrict the domestic use of gold and silver for luxury items and ban luxury imports entirely. Things like Chinese porcelain and Japanese cabinets, arguing they were useless, and just drained the country of precious metals.
And his administrative efficiency was incredible.
He boosted the mint's output by 800%. He fundamentally stabilized the nation's currency and ensured the success of the recoinage.
It's just incredible to think about the scope of his life. We also know that in 1698, Tsar Peter the Great visited the mint at the Tower of London multiple times.
To observe the whole process, yeah. It's certain that Sir Isaac Newton, the Warden of the Mint, was his personal guide.
But even with this crushing schedule at the mint, his intellectual reputation was still a target for his rivals on the continent.
It was. On January 29, 1697, he gets a challenge from Johann Bernoulli to solve the extremely difficult brachistochrome problem.
Which is what, exactly?
Determining the curve of quickest descent for a particle under gravity. It's a hugely complex math problem.
And Bernoulli's letter wasn't just academic. It had a pointed, veiled barb aimed right at Newton and the English mathematicians.
Suggesting they claim to rule through methods which they value so highly. It was a scientific gauntlet thrown down, demanding he prove his supposed superiority.
And the famous story, which is true, is that Newton solved it in a single night.
A single night. He submitted his answer anonymously the very next day. Bernoulli recognized the author instantly, famously remarking, "We recognize the lion by his claw."
But Newton was characteristically bitter about the whole thing.
He was. He remarked that foreigners were compelling him to engage in mathematics and thereby divert him from the king's service. He was brilliant, but never gracious about having to prove it.
And this incident was really the final spark in that long, bitter, and profoundly destructive battle with Gottfried Wilhelm Leibniz over who invented calculus.
The Calculus War.
Newton's position was simple and absolute.
He discovered fluxions first, in 1665-66, and therefore he held eternal priority, even though he didn't publish. He genuinely believed that timely publication granted no rights whatsoever.
But Leibniz's position was just as forceful.
He discovered the method independently, and crucially, he published it first in 1684, and he used the far superior notation, the dx, and the integral sign. They created a universal, accessible algorithm.
English science was held back for decades because they clung to Newton's awkward symbols out of loyalty.
They were. And the dispute turned into this massive international scandal. The Royal Society, led by its president Newton, created a committee to investigate.
And their report, the Commercium Apostolicum, basically concluded that Leibniz had stolen the idea.
It was a weaponized historical document. The German camp, including Bernoulli and Leibniz, retaliated with anonymous pamphlets, the flying sheets, calling Newton a plagiarist who had stepped over the boundaries of honor.
So it expanded far beyond math.
It became a deeply personal and nationalistic war that pitted the two greatest minds of Europe against each other and consumed so much of their later lives.
So by 1713, the first edition of Newton's masterpiece, the Principia Mathematica, it had become a valuable rarity.
It was selling for up to 2 guineas, a fortune. Students were having to copy the entire book by hand, so a second edition was needed.
And this revision, it wasn't just an academic exercise, it had a profound theological agenda behind it.
Heavily supported by Richard Bentley, the master of Trinity and the editor. Bentley wanted to use Newtonian physics as the definitive argument against atheism, against Hobbesian materialism, against Cartesian mechanisms.
Bentley famously argued that physical facts proved God's existence.
Right. He pointed out, for instance, that the Earth's precise location relative to the sun, not too close to burn up, not too far to freeze, was clear proof of divine providence. It shows you how intertwined natural philosophy and religious apologetics were at the time.
And a young mathematician, Roger Coates, played a huge, if understated, role in this revision.
Monumental. He meticulously reviewed the manuscript, offering substantial corrections, raising important questions, especially about the dynamics of motion and fluids in Book 2.
And Newton, who is known for his stubbornness, actually accepted many of Coates' objections.
He did, which is a rare admission for him, but he did reach his limit. When Coates pushed him too hard on some of the algebraic details, Newton shot back this testy little note saying, "It seems to me that the public can swallow it as it is now."
The implication being, stop asking questions.
Exactly. Coates was shut down. A reminder that even the greatest genius preferred efficiency and finality over infinite rigor.
In this second edition, Newton formally introduced his Redile Philosophandi, his rules for reasoning in physics,
codifying his scientific methodology for the next 2 centuries.
Rule I was the foundation of scientific parsimony. Admit no more causes than are true and sufficient to explain phenomena. Basically, nature is simple.
And Rule 2 mandated consistency. Assign the same causes to the same natural effects. The fall of a stone in Europe is the same as the fall of a stone in Africa. The light from a kitchen fire and the light from the sun come from the same principles.
This rigorous methodology created classical physics, but Newton, in a demonstration of brutal honesty, left this profound hole in his own system.
In the General Scholium, right after his theological arguments, he admitted that he had not yet been able to demonstrate the cause of gravity.
He couldn't explain why it was proportional to mass, or why it worked across vast distances, or why it followed the inverse square law.
He simply stated, hypotheses non fingo. No hypotheses. He preferred to leave the cause unexplained rather than revert to discredited Cartesian vortices, or, even worse, what many of his contemporaries would call occult qualities.
The kind of magic he was secretly pursuing in his lab.
Exactly. And yet, paradoxically, he did flirt with these non-mechanical, almost occult ideas in his other major work, Optics.
The sensorium of God.
He asserted that infinite space might be the sensorium, the sensing organ of a non-material, living, intelligent being. God, a being who perceives all things immediately by presence.
The implication of that is enormous. If space is God's sensing organ, then God is immanent inside the physical reality of the universe.
Which skirted perilously close to heresy. Or pantheism, the idea that God is nature, which was deeply offensive to the Orthodox Christian belief in a transcendent, separate creator.
And when he realized the danger, he panicked.
In a spectacular way. He rushed to the printer, bought up the existing copies of the book, and physically replaced the page that mentioned the sensorium of God with a much safer, heavily edited version.
Wow. The fear of controversy was so great that he was willing to physically alter the published record.
Late in his life, Newton continued to speculate on these grand cosmic cycles. He was trying to define the universe as a self-sustaining, if slightly mysterious, machine.
He theorized that vapors and light from the sun gradually condense, first into moons, then into planets like Earth.
And as these planets age, they grow into comets, which eventually fall back into the sun, refueling it to compensate for the constant loss of heat and light. A perfect cycle.
And despite his global fame and the substantial wealth he accumulated, he ended up with 32,000 pounds, an enormous fortune. She lived remarkably simply.
He did. He served as the longtime president of the Royal Society, establishing new rules of decorum, like requiring all discussions to be in English and ensuring the presidential mace was always present when he led the meetings.
Nearing the end of his life, he offered that famous reflection on his own work.
comparing himself to a boy gathering smooth pebbles and beautiful shells on the shore of a vast ocean of truth.
And it's so essential to remember that for Newton, this truth was singular. He valued his theological and historical works, his chronology of ancient kingdoms, his history of prophecies, no less than the Principia or optics.
For him, the divine order he found in nature was completely inseparable from the historical and religious truth he sought in ancient texts. It was all one project.
What a complicated life. We've seen this incredible contrast between the secretive, volatile alchemist and the cold, systematizing mathematician who, in his own words, only saw further by standing on the shoulders of giants.
Even if, in private, he used that very phrase to mock his bitter rival, Hooke. The tension in Newton's life is just profound. This relentless drive for certainty, for order, for quantitative precision that created classical science.
Constantly battling the non-rational, speculative, and deeply isolated parts of his own nature.
Exactly.
We've seen how this man, the great rationalist, spent his final years frantically trying to plug the philosophical holes in his own system, like the cause of gravity, and how he panicked physically removing the page that describes space as the sensorium of God from his book for fear of igniting a deadly theological controversy.
Knowing that the mechanical universe he gave us was born from a man who was simultaneously obsessed with turning lead into gold, and who was willing to entertain these occult or theological explanations when the purely mechanical ones failed. Well, it raises a massive question.
What does Newton's secret life tell us about the true, porous line between natural philosophy and speculative theology at the very dawn of the Age of Reason?
Something to mull over as you see the order he imposed on the world all around you.
Join us and keep your curiosity well fed. Who knows? The next video might be exactly what you didn't know you needed.